our presenter, as we all know him, he is Dr. Derek. He is a man of wisdom, someone who knows everything about IT. He knows everything about OnPassive. He is here to teach all of us what OnPassive is all about. You guys know him very well, right? He's someone that we respect because he is very, very knowledgeable. I want to take this moment for each and everyone to welcome our one and only Dr. Derek. You're welcome, sir. Doc.
Peace, blessings, and enough love to everyone. I just want to say thank you, Dr. Benny Blessings. I really appreciate that introduction, but I don't know everything. And, you know, I don't know everything about OnPassive. I don't know everything about technicals. You know, I learn a few things since I am here, especially with engineer Mike and, you know, Lynn Nakamoto. You know, I have learned some things. So no, I don't know everything. My apologies if I, and I don't know everything about OnPassive. But I do know a few things, and today I'm going to share a few things with all of us. Thank you very much, Pastor George 360. And thank you very much, Lily Lane. That's my little friend over there. Okay, wonderful. All right, thank you everyone for joining us this evening, right there in Africa, Nigeria, or wherever you are at this time, whether it's night, evening, morning, or day. I welcome everyone to this webinar also, and thank you very much for coming. I appreciate serving this group. I really do, and I thank you for having me here to actually serve this group. Today I'm supposed to be speaking on data center and what is a data center and all of that. But one of the things that is very important in respective to where a data center is concerned that I have to make mention, and people, from once you have technical equipment in your house, a computer, a laptop, anything technical, a printer, anything technical, especially, you're going to need what is known as a UPS. So what is a UPS? Let us kind of start there, because this item is very, very important in respective to where a data center is concerned. And we're not talking about the parcel service, the United Parcel Service. That's not what we're talking about in the US when we talk about UPS. We are actually talking about uninterruptible power supply. Uninterruptible power supply, and it ranges from some big units that you use in data center to what people use in their offices, and also this little one here, what you can use in your house to protect your equipment that you might have in your homes. And so most people might not know, but the UPS is much 150% better than your surge protectors that you might buy for like $20, or sometimes some of them run up to $200 US. But with surge protector, the only thing it protects on the alternating current, and that is AC, the current that comes out of your socket from the wall. It's alternating. So yes, it surge up, but it also drops. And sometimes it drops below what is required. And so surge or undercurrent burn up surge protectors, and sometimes we wonder why. When incoming utility power drops below or surges above safe voltage level, the UPS switches to DC battery power and then inverts to AC power to run connected equipment. So it's very important. Simple diagram is normal flow. It goes to a static switch, and the normal current runs through, also charging the battery at the same time. And when the current goes below or goes up or cut off totally, then the switch automatically with AI is going to switch over to the battery. And so these are some uninterruptible power supply that runs data center. And these are a few of them that actually runs data center, especially these rack mount uninterruptible power supply. These are the real types that run major data centers across the globe. And that is how it looks into a rack. So let me kind of feature how all of this put together in terms of a data center. And so the best but expensive power setup is to have two different sources of electrical power grid coming into your data center. But this is very expensive, very expensive. And so the more cost-effective way is to bring in one power grid, and that of course is diesel generated, and this cost-effective way is a little better. This diagram, the diagram gives us a layout of the schematics of how this all put together in terms of a diagram. So let us take it individually. The powers come in from the power grid, and this power that comes from the power grid is normally in the US from 2 to 30 plus kilowatts. 1 kilovolts equal 1,000. And so that has to convert to 480 volts to go to the building. And that 430 volts is then goes to a switcher that switches whenever there's a brownout, blackout, or short-term power interruption. And that sends a message to the generator that chips in. You know, the generator takes a little while to chip in. And so therefore, this is when the UPS takes over between when the power outage and when that generator fully comes to power to run the entire data center. The equipment to bridge the gap, of course, we said it was the UPS. And this is a diagram of how the UPS and also the PDU, which is a power distributing unit, works. And so the UPS, which is a ride-through power, it actually generates the power, whether by flywheel technology or by battery technology. And that is where when the power grid comes back on now, then it switches off the generator automatically and also send a charge back to the UPS to charge up back the UPS, and then everything runs normally as how it's supposed to run normally in that data center. And so when we look at even bigger data centers, they might even have other powered operated units to generate power. This one that is actually Google data center in Netherlands. This one actually uses also, in addition to the power grid, this one uses a windmill power source, which brings power also to that power unit that generates power for the data center. And so therefore, that is very, very important in respective to where a data center is concerned. And this is a generator that is used sometime to generate that power, standby generator. It has to be very big, pushing some big power for the data center. But back to the uninterrupted power supply, you need this instead of a surge protector. Surge protector means nothing in the house because sometimes it still burns up. So try to get a UPS, uninterrupted power supply. Now into the making of what is a data center, one of the most important item or another important item is of course the server. Now this is a diagram of one individual server which can run you approximately $1 million. $1 million for one of these surge protect of one of these servers actually can run you about $1 million. So they are not cheap. These things are not cheap. When you look at a server now into a server rack, you're talking about there are about 10 to 14 servers that will come into a server rack. And this is how the layout would look into a data center. These are how servers look. And then, of course, the uninterruptible power supply is also included in that whole process. Inside of a data center, that's how the layout will look inside of a data center. And of course, this is outside of a data center. And it's massive. Talking about 104 acres of land that this data center is actually on. And you're talking about $200 million worth of data center. But there are a few types of data center: managed, enterprise, colocation, cloud, edge, and hyperscale type of data center. And we're just going to quickly look at these few different types of data center. One of which is a data center there in Hong Kong, and that is the collation data center. Now, that refers to the company that rents the entire facility. So you can either rent the entire facility of a collation data center, or you might be able to just rent a rack, because that's what your business need. The only thing your business need is maybe one rack of about 10 to 14 servers. And so you might want 2 racks or 3 racks, but it all depends on what your business needs are. The managed data center, and this data center can be either completely or partially managed. So some of the management is actually done by you as the person renting the data center, or by the persons that own the data center. In the former, which is the complete, all technical details and back-end data are handled or administered by the data center provider. Whereas the latter, which is partially managed, it allows business to have a certain level of administrative control over the data center, implementation, and service. The enterprise data center, and that is the Google data center that we showed earlier in Netherlands. The enterprise data center is a private facility designated for the sole purpose of supporting a single company. It can be located on premises or off premises at a site as per the customer convenience. Let us look at an example. If, in other words, if you are running a website from Canada or from Nigeria, and your target audience is students in the United States, you will prefer a building or to build a data center in the US to reduce page load time. Let us look at our cloud service data center. The actual hardware is run and managed by the cloud company, often with the help of a third-party managed service provider. It allows clients to run website application and manage data within a virtual infrastructure. Running on cloud servers, the data is fragmented and duplicated across numerous locations as it is uploaded to cloud servers. In this case of any unexpected event, the cloud provider makes sure that there is a backup for your backup as well. A few cloud service companies offer customized cloud, giving clients singular access to their own cloud environment, known as a private cloud. The public cloud provider, on the other hand, makes resources available to the public via the internet. And this is like Amazon and Microsoft. Those will be public, of course. Then you have the edge data center, a smaller facility located close to the population where it serves, characterized by their size and connectivity. These data centers allow organizations to deliver content and services to local users with minimal latency. And we look at latency some time ago in respective to where the difference between the signal, when the signal comes in, you know, it depends on the millisecond, and that is also for internet users. They play a critical role in the edge computing architecture, which brings data storage and computation closer to the location where it is needed. Then the last one that we are going to look at quickly is the hyperscale data center. It's a massive business critical facility designed to effectively support robust, scalable application and are often associated with big data providing companies such as Google, Amazon, Facebook, IBM, and of course, Microsoft. So what is a data center? And that is what we are going to look at now. A data center is a facility composed of network computers, storage systems, and computing infrastructure that business and other organizations use to organize, process, store, and disseminate large amount of data. Enterprise data center increasingly incorporate facilities for securing and protecting cloud computing resources, as well as in-house, on-site resources. As enterprise increasingly turn to cloud computing, the boundaries between cloud providers, data centers, and enterprise data centers becomes less clear-cut. So almost they are becoming the same. The enterprise and also the cloud data centers kind of becoming one in the same. A data center facilities enable an organization to collect its resource and infrastructure for data processing, storage, and communications, which includes 1, systems for storing, sharing, accessing, and processing data across the organization. 2, physical infrastructure to support data processing and data communications. 3, utilities such as cooling, electricity, network access, and uninterruptible power supply. And we took a look at that important feature in the data center earlier. Gathering all these resources in a data center enable the organization to protect proprietary systems and data, centralizing IT and data processing. Employees, contractors, and vendors apply information security control to proprietary system and data, and realized economies of scale by consolidating sensitive system in one place. So let us look at a diagram that kind of, you know, a simple diagram that kind of gives the layout. So say for argument's sake, one user is using a computer in Jamaica, another user is in Nigeria, and another user is in the US or in the UK or in Japan or wherever that user is. That user goes up to that web service that he's actually using, and then from the web service, it goes to a load balancer. Then your outgoing request goes into what is known as a virtual machine, and then from the virtual machine to whichever data center that it might apply to. So whether it's Japan, US, or the UK, then it goes into that data center, and then the incoming requests that you outgo request is now coming back to you in that incoming request. And so that is the way, just like how we are all plugged in from all over the world. We are all plugged in to the different servers or the in-house small data center that OnPassive has in Hyderabad. All of us goes into that data center through your web service and through the virtual machine. And that virtual machine allows a business to run an operating system that behaves like a complete separate computer in an app window on a desktop. And so that is the process, or the easy process of how the flow of getting into a data center. Of course, there are many data centers across the globe right now, with the US having the most data centers, with over 2,000 data centers in the US, over 400 in UK and in Germany, and over 200 data centers in Canada, France, Netherlands, Australia, and over 100 in Japan. Let us now look at the tier, data center tier. The first tier is, these are the most basic type of data center, and they incorporate a UPS for backup, of course. Tier 1 data center do not provide redundant systems backup, systems, which is a backup or a fail-safe kind of system. And so you might have some downtime. The guarantee is 99.671% of uptime. That's what that one guarantees. The tier 2 data centers, these data centers include system, power and cooling redundancy, and guarantee at least 99.749 uptime. The tier 3 data centers provide partial fault tolerance, and it is guaranteeing or telling us that 72 hours of outage protection. In other words, if the current gone completely from your power grid, power cut, as we might call it in the Caribbean, power cut, power gone, no power from the power grid. What the tier 3 level of data center providers is guaranteeing you at least 3 days. So you can be running that data center. That data center will be up and running for 3 days without any power from the power company. 99.982% of uptime guaranteed. Wow. And full redundancy, of course. And of course, tier 4, the tier 4 data centers guaranteed 99.995% of uptime, or no more than 26 minutes for the year. 26 minutes for the year of downtime. That is very impressive. Of course, as well as full tolerance, system redundancy, and 96 hours of outage protection. Most big company, this is the one that they go for, the tier 4, because we're talking about 4 days of outage protection. OnPassive, I don't know if they're going to come with tier 5, because Ashmafari always over-deliver. So we don't know. This is not in the schematics of tiers. So don't get this confused. We only have 4 tiers right now in data center, but as according to Ashmafari and what we witnessed so far, Ashmafari always over deliver. And one of the things that he always over deliver with is artificial intelligence and machine learning. So right away, that is a over delivery. So we might have to have 5 tiers instead of 4 tiers in respective to where the types of data center that we have when OnPassive fully comes with their data center. And so we are still on the balance in respective to exactly what our data center will offer. But I definitely know it's going to offer more than 99.995% of availability because, as I said, OnPassive always over deliver. And we witnessed to that so far as founders. So let us take a look at what OnPassive data center strategy is about. And therefore, OnPassive data center strategy is going to be looking at these few things. It is an era in business that plays a significant role in gaining the best result. Role of AI in data strategy. Data strategy increase revenue and profit, and every founder should smile where that is concerned. AI helps in database management. That is a thumbs up for users. AI boosts as a greater strategy in business. AI helps in tracking data challenges. Benefits of using AI in data strategy. Of course, this is going to reduce the cost of purchasing, setup, startup, and consulting IT. Reduces costs of maintaining outdated system and applications. Increases the speed at which decision making is made. Improves the organization ability to integrate all the pieces of business. And of course, it will create a framework of gathering, assimilating, and analyzing the relevant information and enable business to build better relationships between customers and suppliers. So that is a look at our data center. And of course, what does that mean for us as founders? It means that percentage of sharing in the revenue is going to be, you know, a major thing. And the difference between a reseller and a founder, that is one of the major difference between reseller and a founder, is actually percentage share in the revenue. And this is why it is so important for us as founders that are founders, that a lot of things that are going to be still coming, because OnPassive don't finish product building at 20 or 50 or 100. OnPassive product building is going to continue and continue and continue and continue. And this is where, these are where product sharing is going to be very, very important to all of us to be part of this wonderful company as a founder in OnPassive. I thank you very much.